Hello class, so this is another integral we'll be trying to evaluate. So the integral is in the concepts of trigonometric substitution. So as you can see, the integral is long. We'll have to perform very long. So from start, we'll start by evaluating this part. So as you can see, this part is just the same as 4x squared plus 9, okay? I'll place a square root, okay? Then I'll cube that part. From there, so this is what I'm having. So I'll try to express this to this. So I'll write now my integral as, we're trying to simplify, so I'll write my integral as the integral from 0 to 3, the square root of 3 divided by 2, x cubed divided by the square root of 4x squared plus 9. All these things and cube it with x. So after that, I will try to factor out my 4. As you can see, this is the square root of 4x squared plus I'm trying to manipulate the integral to resemble the formula on trigonometric substitution by tan. So from there I'll try to factor out my 4. So I'll get the integral from 0 to 3, the square root of 3 divided by 2, okay? X cubed divided by, so from now, let's factor out 4 from here, okay? So we'll say the square root of, I'll factor out my 4, I'll get my 4 into x squared, okay? Plus, so what will I write here? I'll write 9 over 4, okay? I'll write 9 over 4, okay? Such that when I multiply 4 multiplied by this, I'll get 4 this. This multiplied by this, I'll get 36 over 4. It's just the same as 9, right? Then, after factoring that, I will cube. Remember, there's cubed somewhere. And then write my dx. So this is where we have reached. So from there again, let's continue simplifying. So we just continue simplifying till the integral looks a bit easy. So we'll say again the integral of from 0 to 3, the square root of 3 divided by 2, okay? X cubed, okay, divided by, so this I can say the square root of 4 multiplied by the square root of that part. So I'll say, what's the square root of 4? So I'll say the square root of 4, okay, multiply again by the square root of this part, so it's x squared plus 9 over 4, and that whole thing, it's being cubed, okay, don't forget that, don't forget the cubed part, so that is the x. So that's where we have reached, okay. So from there, we'll try to perform the square root. So what's the square root of this part? So the square root of 4 is just the same as 2. Then from here, okay, the rad of x squared plus 9 over 4. I'll try to express 9 over 4 in terms of the square root. So I'll say, I can say 9 over 4, when I find its square root, okay, then I square it, it will just be the same as 9 over 4, right? So what's the square root of this part? So the square root of this part is just the same as 3 over 4, 3 over 2, okay? Then if I square that, I'll get 9 over 4, okay? So I'm trying to manipulate the integral to resemble the formula of integration using trigonometric substitution. So instead of writing 9 over 4, I'll write 3 over 2 squared, right? So from there, I'll write inside, I'll write 3 over 2 squared, remember? So I'll write 3 over 2 squared. Okay? So as you can see, now this the integral shows trigonometric substitution by now, the tan. When you see something like this, I'm told to express your x in terms of tan. So I'll say my x equals to a tan of theta, right? So from there, what's my a? My a, this is the part. Remember the integral formula usually says when you're integrating the rad of a squared plus b plus x squared, plus x squared dx, you are told to choose your x as a tan of theta, right? So this is what we have been trying to manipulate. So as you can see, a squared, this is x squared, a squared resembles this part. So it means our a squared is the same as all this thing, 3 over 2 squared. So the square goes with the square, I'll get my a as 3 over 2. Okay? So that's my value for a. So from there, I'll get it as 3 over 2 tan theta. Right? That's my x. I have my dx, so automatically I'll have to find my dx again. For me, I'll get my dx to be 3 over 2 secant square of theta. Right? So again, I have my x cubed. I'll have to get my x cubed. So I'll get my x cubed to be, multiplying this, it's cubed of 3 is 27, divided by cubed of 2 is 8, okay? Then cubed of tan, I'll get tan cubed of theta. Okay, from there again, I have my x squared, I'll have to get my x squared. So what's my x squared? My x squared will be 9 over 4, okay? Tan secant theta. Right, from there, let's replace all the information inside the integral. So it says the integral from 0 to 3, the square root of 3 divided by 2. So what's my x cubed? My x cubed is that, so I'll write 27 divided by 8 tan 3 of theta divided by what's the square root of 4? So remember the brackets. So the square root of 4 is just 2, okay? Multiplied by, inside the sum, multiplied by the square root of, what's my x squared? I'll replace my x squared with that, so I'll write my 9 over 4 tan square of theta, okay? Plus, what's 3 over 2 squared is just the same as 9 over 4, okay? So remember, all that expression has been cubed, okay? Multiplied by, what's my dx? My dx, as you can see, what's my dx from here? My dx is 3 over 2 multiplied by secant squared of theta. Secant squared of theta. So once we have reached here, we just continue trying to evaluate. So from there, so let's factor out 9 over 4 from this part. So we'll say, okay, this part. So factoring out 9 over 4, there's an integral here. So it's this way. There's an integral here, 3, the square root of 3 divided by 2, remember. So let's factor out our 9 over 4 from here. We'll get 3 the square root of 3 divided by 2, the integral from 0 to that. These are the bounds. So 27, this is 27 divided by 8 tan of theta divided by, I'll place my 2, okay, but inside a very big bracket, I'll factor out my 9 over 4, remember? So it will be multiplied by the square root of 9 over 4 into tan squared of theta plus 1. Okay, all this part, I cubed it. This cubed, it's there. Okay, multiply by 3 over 2. 3 over 2 secant squared of theta. So from there, what's the square root of 9 over 4? I'll just write again. Try to go fast, step by step. So I'll get the integral from 0 to 3, the square root of 3 divided by 2. Here I'll write my 27 over 8 tan of 3 of theta divided by the square root of this part multiplied by that. So I'll get 2 multiplied by 3 over 2. Okay? Again, multiplied by the square root of tan squared theta plus 1. So remember my particular identity that says tan squared of theta plus 1 is the same as secant squared of theta, right? So all these parts I'll replace with my secant squared. So I'll replace by my secant squared. So I'll replace my secant squared of theta. Okay? Remember all this part is being cubed, multiplied by 3 over 2 secant to the square of theta. So what's secant squared is just the same as single secant. This is the square root, so I'll just multiply by the secant alone. So I'll multiply by the secant of theta alone. So from there, let's cube our part. So cubing 3, cubing 2, we get 8. Cubing this, so 2 can go with 2. Okay, so I'll write the integral from 0 to 3, the square root of 3 divided by 2 to be, okay, so from there we say, okay, so we'll just continue. So it will be 27 over 8 tan cube of theta divided by the cube of this part, it will be 27. Okay, multiply by secant cube of theta, multiply by 3 over 2 secant. Remember, it was d theta, remember? Secant squared of that d theta. But before that, before we continue, we'll have to change our bounds. It was now, the one was dx, which we'll try to bring the bounds to the d theta world, okay? To the d theta world. So from dx to d theta, we'll try to change the bounds from this part to this part. So that's what we'll be looking on. Let's change the bounds. So as changing the bounds, we get we'll have to change our bounds from dx to d theta. We removed our integral from dx to d theta. So we'll say, remember our equation was x equals to 3 over 2, right? 3 over 2 tan of theta, right? So from there, I'll say, I'll replace my x, okay? I'll replace my x with 0. So I'll get 0 equals to 3 over 2 tan of theta, okay? So what's my tan theta? My tan theta will be 0, right? So my tan inverse of theta, okay, my theta alone, so what will be my theta alone? My theta alone will be tan inverse of 0. What's tan inverse of 0? I think it's just the same as 0. So from there again, so I've found my bound to be 0 for the theta world now. So again, what's 3 over 2 for the theta world? It will be x equals to 3 over 2 tan of theta. But now I'll change my x to be this part. So I'll write 3, the square root of 3 divided by 2 equals to 3 over 2 tan of theta. Okay? multiply by the reciprocal. This part goes this goes this. Okay, so I'll get my square root of 3 equals to tan of theta. Okay, so my theta alone will be tan inverse of square root of 3. I'll get my theta alone to be 60 degrees. Okay, so what is 60 degrees? I'll express that in terms of pi. So this is just the same as pi divided by 3. Okay, so in the theta world, we'll replace this part with 0, the same as 0, and then this upper part, we'll replace this part with pi over 3. Okay, so that's our bounds, as you can see. So that's how we change the bounds. Okay, and these concepts of changing bounds only applies on substitution, where you substitute, where you change when you're given bounds, okay, and you're trying to change from dx to d theta or d theta to du, we'll have to perform that small change to the bounds. But whenever there are no bounds, no need for changing, right? So let's eliminate our parts here, as you can see. So let's eliminate the constant terms outside. So we get the integral from pi now over 3 to 0. 27 over 8, take it outside into, so it will be 27 over 8 again, divided by 27 over 8, okay? 27 over 8 multiplied by 3 over 2, multiplied by 3 over 2. As you can see, so it will be remaining outside the integral, it will be the integral of tan of theta, okay, divided by secant cubed of theta, okay, multiplied by secant squared of theta d theta, right? So from there, as you can see, these will go with that using the reciprocal, okay? So we'll get, I think we'll get, okay, where is it? Where's our 3 over 2? So just remain with 3 over 2 there. Okay, the answer will be, so the answer will be 3 over 2 multiplied by that part, so it will just be the same as multiplied by 8, so I think it will be multiplied by 1 over 8, not 8. So our answer will be 3 over 16. Okay. So from there, as you can see, so taking all these constants outside, evaluating that, you get 3 over 16. So from there, let's cancel out this part and this part. Okay. So I'll say, I'll cancel this, will be remaining 1, cancel this, will be remaining 1. Okay. So I'll get 3 over 16, the integral from 0 to pi over 3 multiplied by, what's my tan theta cubed? Tan theta cubed is the same as sine of 3 theta divided by cos of 3 theta, right? But now there's a symbol secant theta below the denominator. So what's my secant theta from the Pythagorean identities? We say secant theta from the reciprocal identity, so it is the same as cos of theta, right? So I'll be multiplying by my cos of theta divided by 1. Okay? Don't forgetting to place your d theta. Right? So from there I'll get my 3 over 16, the integral from 0 to pi over 3. So from this part I will remain with my secant, my sine, not secant, sine of 3 theta divided by my 1 cos will go with that, I will be remaining with cos to the second. Okay? Cos to the second of theta, d theta. So from there, again, we'll find our answer as, so from here, I'll split the upper integral as, okay, let me just write from here, I'll split this integral as 3 over 16, the integral of sine squared of theta multiplied by sine of theta divided by cos squared of theta d theta. So remember from our trigonometric integrals, so we haven't placed my bounds are pi over 3 from 0. From our trigonometric integrals, not integral 3, trigonometric integrals, we say, given something like this, we'll try to eliminate this part, Try to eliminate sine of theta, we usually choose our u, So I'm told, choose your u to be something such that when you find the derivative of that part, it will get to cancel out, it will resemble that part for easy cancellations, So usually we shall say, choose the opposite for sine, and the normal opposite for sine is just cos of theta. So when I find my derivative du, I'll get negative sine of theta d theta. So from there, I'll replace inside my integral with that part. So I'll get 3 over 16, the integral from pi over 3 from 0. What's my sine squared? Again, my sine squared, I can just write from the Pythagorean identity, we know cos squared of theta plus sine squared of theta is the same as 1, right? So my sine squared is just the same as 1 minus cos squared of theta. So I'll write 1 minus cos squared of theta, that's my sine part, multiplied by my sine of theta, right? Then I'll divide by my d theta. But what's d theta from this part? D theta is the same as du divided by sine of theta. So I'll be multiplied by du over negative sine of theta. Negative sine of theta. Then from there I'll divide by my cos squared of theta. So again, from this part, we have seen we are trying to move from the d theta world, to the du world. So again, we'll have to perform how to change the bounds again. So we'll have to change the bounds again. So as changing the bounds, we'll say what was our choice of u. So our u was cos of theta, right? So I'll replace my theta with 0. So I'll say my u1 to be cos of 0. Cos of 0, not cos of theta, cos of 0. Then again I'll say my u2, the second bound, to be cos of that part. So it will be cos of pi over 3. As you can see, what's cos of 0? 1. What's cos of 60 is just the same as a half. So again, I'll have to change my bounds from 1 to that part. So from there, I'll get my 3 over 16, the integral from now 1. The bounds have changed to a half. Remember, so the trickiness for this example is how to change the bounds, remember? But the same procedure for trigonometric substitution applies. So the problem is changing from dx, we changed from our dx to d theta, then from d theta to du. So you have to change the bounds, remember? Once given any bound, changing from d theta to d theta, you must change your bound. So from there, let's replace our integral to be 1 minus what's our u? Our u is cos theta. So cos squared theta is just the same as u squared. So I'll get my 1 minus u squared, multiplied by sine of theta, multiplied by du, divided by negative sine of theta. From there again, I'll divide all that thing with cos squared of u. What's cos squared of u? So cos squared theta is just the same as u squared, right? So as you can see from here, my sign cancels with the sign and remaining is negative, remember? So this negative, I'll take it outside the integral, so I'll get negative 3 over 16, the integral from 1 to 2, 1.5, okay? From 1 to a half, from 1 to a half, 1 minus u squared, okay, divided by u squared, okay. I'll write my du. Okay, from that part, we'll just continue. So from there, there's a trick there. I'll have to explain. That. So once you have a negative sign outside the integral, there's a property in class 2 that allows us to change the bounds by eliminating the negative sign. So I'll change my bounds, I'll opposite my bounds, I'll get the integral. From now, instead of writing 1, I'll place a half here, I'll place my 1 there. So my half here, so I'll be placing my half, okay, to 1. This negative reciprocates the bounds, so I'm remaining with my 3 over 16, okay? So from there, I'll just say 1 divided by u squared divided by that part. So I'll just get 1, I'll be splitting the denominator, so it's just u squared minus 1 minus u squared over u squared. It's just one and the same thing, du, okay? So from there, as you can see, this part cancels with this part, just remaining with 1. So I'll write my 3 over 16, the integral from a half. Now remember, 1 over u squared. Again, I just have to split my integral into 2. Okay, no need for splitting, but you can split. I'll say my du minus the integral from again a half to 1 of 1 du. Okay, this part is 1, so no need for splitting, but you can just split. So from there, what will we get? So as you can see, the integral is very long, so I'll get my 3 over 16. But remember, 3 over 16, it's for the whole thing, okay? So let's place our 3 over 16 aside, multiply that with the result of our integration. So for me, this part, I can say, I'll reciprocate this part, so I'll get the integral of u to the second, right? Du minus the integral. What's the integral of 1 with respect to u? It's just u. Okay? Don't forget the bounds. The bounds is from a half to 1, a half to 1. Okay? So what's our integral for this? This is just the same, adding 1 to the power divided by the result of the power. What will you get? We'll get u. We'll get u divided by -1, right? And remember, we have bounds, so placing the bounds for that part, it will be a half to 1. So this is the first part. Okay, so the first part, then you'll minus that. The second part, what's the second part? The integral of 1 with respect to u is just the same as u. So I'll write my u, and again it has bounds from a half to 1. Okay, that whole expression multiplied by 3 over 2. 3 over 16, sorry. So let's evaluate this part. So this part is just the same as u negative of what's that part. So this is the same as 1 over u, right? But what is our u? What's our u? We said our u was cos. Okay? So that's the same as cos of theta. Okay? From a half to 1 minus what our u there, it will be cos of theta from a half to 1. So let's replace that. We'll get negative 1 over cos of, so I'll be replacing my 1 here. It will be cos of 1. What's my cos of 1? Cos of 1, cos theta of 1, it's 0. Yeah, same as 1. So I'll get my reciprocal for that. So I'll get 1 divided by our answer. All this part I'll get 1. Okay? 1. But remember the negative is for all the things, so it's 1. Then I'll minus cos to the half, so it's my cos was 0.5. Then I'll say 1 divided by that answer. I'll get again 1. Okay? So it's 1 minus 1. So it will be my answer. But remember the negative part multiplies all. So I'll get negative 1 plus 1 is just the same as 0. So all these expressions will be 0. Okay? So this other part will be 0. So I'll be cancelling that part. So this part will be 0, as you can see. Then I'll be having 0 minus, again, what's cos of 1? Cos of 1 is just the same as, okay, I'll just write cos of 1. Cos of 1 is 0.9998 minus cos to the half, cos of 0.5. 0.999. Okay, so from there, what's 0.99? This minus this. So guys, from there, this is our final expression. So from here, we'll just be replacing a half into a 1 to this part to the u. So I'll say 3 over 16. Okay? All that will be multiplied by, I'll be replacing 1 to the u part. Remember there's a negative, so it's just the same as negative of 1 over u, right? Then the bound is from a half to 1. So I'll be evaluating this. So let me first evaluate this part. I'll say negative 1 over, what's my u1? My u1. Then I'll minus that again with negative 1 over, what's my second part? A half. Okay? So from here, what's my answer for that? My answer will be negative 1 minus, the expression for this is just the same as minus 2. We'll get my answer to be negative 1 plus 2, which is just the same as 1. Okay? So from there, this part I'll replace with 1. As you can see, this part is just the same as 1. Okay? So that will be 1. And again, let's evaluate this part. So this part is the same as u. So I'll be replacing my 1 there. So it will be 1 minus a half. Okay? 1 minus a half is just the same as 0.5. Okay? So 0.5. So all these parts I'll get it as my 0.5. My 0.5. Okay? So it's simple that way. So from there, I'll get 3 over 16 into 1 minus 0.5 is the same as 0.5. Okay? So my final answer will be 3 over 32. Okay? So this is my final answer. 3 over 32 is the final answer for the integral. So the integral, as you can see, the integral is very long. It requires time, it requires keenness. I almost forgotten some step. That's why the video took long. But this is how we handle it. So check my YouTube videos on most of the trigonometric integrals, trying to evaluate them, trying to make calculus simple. Okay? So don't forget to like, share, subscribe. It's Lee Professor from the University of Nairobi. Thank you.